Hello everyone, I am Shweta M, Assistant Professor of Computer Science and Engineering in St. Martin's Engineering College. Today, welcome to all for this video session. Today I am discussing about UML diagrams in software engineering subject. Before discussing UML diagrams, first we have to know what is software. Software is a set of operations. In software engineering, we have some key points, that is in software engineering, we have first we have some requirements. Again, operations, design, testing, analysis, deployment. In this, requirements means in for clients what in program which requirements are need. We have to gather all requirements. We have to gather all requirements, then design the model. After test this software and analyze this software, and final the result will be get the clients will get the lesser time in software engineering. In coming to UML diagrams, what is UML? UML is Unified Modeling Language. The full form of UML is Unified Modeling Language. The main aim of UML is to define standardized way to visualize how the system has been designed, and it quite similar to blueprints used in other fields of the engineering. What is unified? Unified is used to visualize the system. It is not a programming language, it is a visualizing language. What is in unified modeling language? Unified is visualizing. In modeling, we have to design the diagrams. We have to design the diagrams like structural diagram and behavioral diagrams, like that. In language means what is language? Language means it is a formal language. It allows the developer and designer and other stakeholders. Stakeholders means clients. Clients to express their ideas and designs and requirements. What are the requirements they need? They will discuss to each other, and so that it will get easier to analyze the project. In this UML diagram, we have two types, that is behavioral diagram and structural diagram. In behavioral diagram, we have activity diagram, interaction diagram, state machine diagram, and use case diagram. In that interaction diagram, communication diagrams and sequence diagrams, interaction overview diagrams, and timing diagrams are there. In structural diagram, class diagrams, composite structure diagrams, component diagrams, object diagrams, package diagrams, profile diagrams, like that is there. In this we have, in this diagram, these are there: behavioral, activity diagram, state machine, use case, interaction. In this interaction, communication diagram, interaction diagram, sequence diagram, and timing diagram. In structural diagram, class diagrams are there, component diagrams, object diagrams, composite structure diagrams, deployment diagrams, and package diagrams are there. In structural diagram means it is the structure of the system. Structure means it is the structure of the what the program structure we need. In this we have the structure of the program widely used in the documentation of the software architecture. In that structural diagram, we have class diagram. In class diagram, it is one of the most widely used diagram. It is the backbone of the object-oriented system, software systems. It displays the system's class attributes and objects and methods. In attributes, in class diagram, we have three sections is there. Three sections is there. The first section is class. Next one is attributes. Next one is methods. In this class diagram, we have to use in this first section only. This is also as upper section. This is the middle section. This is the lower section. In this class diagram, in this class, we have to write only class names. We have to write only class names. The class name should be in must capital letter only. Starting letter is capital and it will be placed in center of the section. And the next middle is attributes. In this attribute we have like this. In the components, vital components of a class diagram, the class diagram is made up of three sections. That is already we discussed now. That is first one is upper section, middle section and lower section. The upper section is class. It will be placed in name of the class only. The name of the class first letter should be in capital letter only. It will be placed in this section middle of the part. It representation of similar objects that shares the same relationships, attributes, operations and semantics. In the middle section of the class diagram, in the middle section, it having attributes. The attributes are written along with the visibility factors, that is private, protected and package. The accessibility of attribute are illustrated by the visibility of factors. The lower section. Lower section contains the method of operations. The method of operations represented in the form of list only. The list is in single line only. The list is written in single line only. It demonstrates how the class interacts with the data. Like this. Class should be in class name, upper section should be in class name, attributes and methods. Attributes means public, private, protected and package. These are only visibility factors in this attribute. And lower section is method. Method means it contains the lower section of the method or operations. It represents the form of list only. It interacts the class. Next, in this UML we have a relationships are there. In these relationships, first one is dependency. Dependency is a semantic relationship between the two classes. That is two or more classes. This is the semantic representation. Dependency. For example, student. In this relationship, that is dependency relationship, we have taken one example, that is student. In student, what we want, student means student name, student ID must be have. because many students have same name, same that is same initial, so that student id must be there. This is the dependency. Student have must dependent in the student id only. That is the relationship, dependency relationship. Next one is student name and student id. Next one is generalization. In generalization, relationship between parent and child class. The parent class is super class and the child class is subclass. The child class is inheritance from the parent class. For example, bank account. In bank account, this is the parent class. These are the child classes, super class and subclasses. In bank account, we have compulsory current account, saving account and credit account we have. Without this, in bank account only, this is the generalization. Next, association. Association means it is a physical connection between two or more objects. In for example, department, two or more objects. For example, department, college is there. In college, many departments is there. Many departments are associated with the college only. That is the association relationship. Next, multiplicity. Multiplicity means it is the specific range of allowable instances attribute. In case of range is not specified, one consider as a default multiplicity. If the range is not specified, one is considered as a default multiplicity. For example, multiple patients are there in hospital. Not any single patient is in one hospital. In hospital means multiple patients are multiple patients are there. That is the hospital and patient. It is admitted in patient are admitted in the hospital only. This is the admission multiplicity relationship. Next, aggregation. Aggregation is it is the subset of a association. It represents the relationship. This it defines the whole part of the relationship. The company encompasses number of employees, and even one employee resign, company still exists. If the company will run, if one employee can resign means company will not exist. The total will not be lost the any issues. And composition. Composition is a subset of aggregation. It dependency between the parent and the child, which means it is one of the part is deleted, then the other part also affected. For example, the company employee. This is the composition. If the in contact book we have consists of multiple contacts is there. If one in contact book only one contact will be deleted, it will not affect the contact book. In contact book total contacts are deleted, contact book deleted the contact book, then it will affect the total, it contacts will be lost. Like this, contact book contact. If in contact book, if any one contact is deleted, it will be not affected. If the contact book total contact book will deleted, it will be lost the total contact numbers. How to draw a class diagram? Class diagram is used to most widely constructed software applications. Some key points are needed to keep the mind in drawing class diagrams. The objects and the relationship should be acknowledged in the advance. In class diagram, we have, for example, we taken customer, order details and item. For what we have, customer means customer should have a customer name and address, which order will be delivered to which address. That is orders. Order, which date customer which date they will order, and status, it will be in process or it will be in on the way, like that. Subtotal, order total, tax, total weight. Next line, if the order is okay, next order details. Order details, it is the quality of the order, and text status of the order. Status means it should be in string only. String means it is the characters. Next, items. Items means items, it is a which item they have to shipping. The shipping weight, description. Description, it will be in string only. String means it is the set of characters only. If the order is okay, then payment. Payment, payment will be in amount. It will be in float type only. Float means that like point, for example, 100.00, 100.01 like that. It is payment will be in compulsory in float point, so float type only. If the payment will be done, then cash is cash tendered. It is will be in floating point, floating type. Next, check and credit. Next, purpose of use case diagram. Following the purpose of use case diagram, it is in gathers the system needs. What the system needs. It depicts the external view of the system. It recognizes the internal as well as the external factors of the that influence the system. It is means interaction between the actors. Actors means in this, these are the actors. In use case diagram, we are using the example by using actors. The purpose of use case diagram, the following purpose of use case diagram, it is gathering the system's needs. What the system needs. It represents the interaction between the actors. If the actors means like this, interaction between the one person to another person. The persons are take place in actors role. For example, in web customer, there are two types. In web customer, there are two types. That is, one is registered customer and new customer. Registered customer means already they are registered in that web. New customer means they don't have any account. If the registered customer is having view item, they view the items and make to purchase the particular item. In the new customer also view the items and client register and have to must register the client. Next, view the items. If the customer items view the items, then authentication is there. Ask the authentication and then identity the provider. Next, checkout. Checkout, after taking in online shopping, they taken any product. We have to they have to purchase. Then check out the two steps. Check out in two steps. That is credit payment service and PayPal. In the view item, first search the item in online shopping. First search the item, browse the item. After browsing, which one we have to require, then we have recommended the item and add to shopping cart. Which one we have to buy, then it is added to the shopping cart and added to the wish list also. After customer authentication, view the recommended items and add to the wish list. Similarly, the checkout use case also include these. It requires the authentication web customer, which can be done in login page. User authentication cookie like remember me or single sign on SSO. SSO needs means it is an external identity provided for participation. Next, in this diagram, checkout customer authentication, calculate the taxes and shippings and payments, view the update and shopping carts. If the customer is authenticated, then sign in the user and remember the user. Single sign, if the sign on single person or multiple person, they have to check out the service authentication. After, update the shopping. If any shopping will they will Purchase, calculate the total total products and calculate the taxes and shippings. Payment, the bills. The payment is credited payment services or debited payment services, like that. In this class diagram, already we discussed that customer, order details and items. We have to, when the designing a system of software developer, it will often the benefits of the class diagram. In the class notation, it is symbolizes the concepts, that is class name, attribute, operations. The class name should be in center of the section. It will be in capital letter only, starting letter, and attributes are attribute A, attribute B, attribute C, like that. Types of attributes and operations, that is operations are like integer, void, like that. Class without signature, class with signature. Without signature means like this, with signature means integers. We are using the which type of attributes, like that. Like this, plus means operation, operations, plus minus hash, like that, integers. The relationship between the classes are bidirectional associations, that is two classes are there. It is represent the straight line connecting the two classes. Next, inheritance. It is a child parent relationship between the classes. The child class is specialized subclass of the parent. Next, two classes is there. This is a realization. One class is implements the behavior specified by the another class. One class is implements that the behavior specified by the another class. Next, dependency. Dependency means as the one class dependence to the another, that is dependency. In this dependency we are using dashed arrows lines. In realization also we are using dashed lines, but here we are using this arrow. In inheritance, it is child parent relationship between the two classes only. Next, bidirectional association means it is represented in only straight line. These are the relationships. Next, aggregation. Aggregation means it is represent the it is relationship between the classes. It is a part of subordinate to another instances, and the child and parent classes can exist independently. Next, composition. It is also a form of aggregation when one class is depends on the another class. One class is depends on the another class. If one class is part of the another, this child class and parent class cannot exist independently. It cannot exist independently. These are the relationships in class diagram. Next, we have to discuss about the what is UML, Unified Modeling Language. After in this behavioral diagrams and structural diagrams are there. There are two types of diagrams. In that behavioral diagram, we have activity, state, mission, use case and interaction diagrams are there. And structural diagram, we have class diagram, component diagram, object, and like that deployment, package diagrams. In class diagram, we are using the three sections in class name, attributes and methods are there in class diagram. Next, relationships are already discussed, that generalization relationship, aggregation and association relationship, multiplicity relationship, that composition. Next, class diagrams are also we discussed. After sequence diagram. In this sequence diagram, it represents the flow of messages in the system. Means it the system, it represents the what messages in flow. In UML, the lifeline is represented by vertical bar. That represented by in vertical bar. Purpose of the sequence diagram: it is a high level interaction among the active objects within a system to model interaction among the objects inside the collaboration, realizing in a use case. What the notion of the sequence diagram? The sequence diagram, it is the line will be in like this lifeline. It is a individual participants. The lifeline, it is positioned at the diagram. Next, actor. Actor plays a major role. Activation diagram. Activation means it represents the thin rectangular lifeline. In sequence diagram, just rectangular lifeline and dotted lines. These lines are. Next, activation diagram. It is a rectangular lifeline, thin rectangular lifeline. It describes that the time period in which an operation is performed by an element. Next, call message. It defines the particular communication between the lifelines, communication between these two lifelines, interaction between the lifelines. They will message from one lifeline to another lifeline. Next, return message. If any message is will return from that lifeline to this lifeline, the communication between these lifelines interaction, it represents the flow of receiver corresponding the message. Next, self message. This interaction that represent message of same lifeline, same lifeline only, it will get back to the message, that is a self message. Next, recursive message. Recursive message means self message sent for recursive purpose. Self message sent for recursive purpose. It is called a recursive message. That is, the diagram is like this. Next, create message. If any communication between particular lifelines means like this. Interaction it has been. Next, duration message. It describes the communication of particular between lifelines interaction with a time passage of the message while modeling the system. Passage of the message while modeling the system. Next, object diagram. Object diagram, it describes the static structure of the system. Next, component diagram. It determines whether the desired functional requirements it have been considered as by the planned development. It depicts the relationship between the elements of the software system. Next, deployment diagram. This is the last diagram. It represents the system software and its hardware by telling what the existing physical components are, what the software components are running on them. The topic is session is end today. Thank you.